Thank you very much, Asunta. Hello and good afternoon, everyone. This presentation is concerned with Aster Yellows phytoplasma in grapevine in South Africa and the management of the insect vectors based, also management of Aster Yellows based on insect vectors and alternative host plants. So Aster Yellows phytoplasma in South Africa is associated with 16S B1 group. Sorry, let's see, it's a spelling mistake, 16SR1B group. And these are some of the typical symptoms. So the yellowing of the leaves, which are crisp and wrinkled, the abortion of the bunches, we have seen it earlier from Johann Berger's presentation, and also another symptom that stems or shoots do not lignify and stay green. So the Aster Yellows phytoplasma in South Africa occurs in 3 regions. In the Western Cape, here in the Western Cape, Cape Town is about here. So in the Walboomsrivier, Robertson and Vredendal. The organism is considered a quarantine organism, and we therefore only could carry out the work in the Western Cape, and most of the work has been carried out in Vredendal. So in order to determine potential vectors and alternative host plants, we used for the vectors yellow sticky traps, which were placed in vineyards, and we used sweep netting and also visual inspection. So for determining or identifying vectors in the natural vegetation, we used vacuum sampling. The yellow sticky traps and the vacuum sampling was used for standardized sampling, so it's concerned with the qualitative survey, which we did in order to determine also the abundance of the different vectors in the field. Then these were stored in ethanol, and at the same time we also sampled the plant samples to determine alternative host plants. So this table shows the results of the leafhopper survey we did in grapevine blocks with yellow sticky traps. So we had 10 yellow sticky traps in grapevine blocks which were replaced weekly, and this started in 2006 until 2019. And based on this data, and the sticky traps were placed in vineyards in Vredendal, which are high Aster Yellows abundance on occurrence. So here Megenia fuscovaria, this is a vector of Aster Yellows phytoplasma, had the highest abundance with 44%. We looked for leafhoppers and plant hoppers, but here in the list we only have got leafhoppers because the plant hoppers only occurred in low numbers. So other leafhopper species which occurred in relatively high numbers are Astrogallia species, Cicadolina, Circulifa, and Axialineatifrons. But even though some of them tested positive for Aster Yellows, we could not show that they could transmit Aster Yellows in controlled transmission experiment. One species, however, which occurred in a very low abundance with less than 1% in grapevines, Acinurella prolixa, tested positive for Aster Yellows and was also able to transmit it to an artificial feeding medium and to wheat plants. So in South Africa, we are dealing with 2 species. The one is a confirmed vector, Megenia fuscovaria, can transmit Aster Yellows to grapevine and also to grass species. And as the potential vector, we identified Acinurella prolixa during the current Tropicsafe project. This is a grass-feeding species, and we could show that it transmits phytoplasma to grasses, but we are not sure yet at this stage whether it can transmit it also to grapevine. So in order to develop a management plan, we also determined the seasonal abundance. So this was also with the yellow sticky traps, which we placed in vineyards. And this, as I said, was done in the Vredendal region. And in the top graph, we can see that Megenia fuscovaria, which occurs throughout the year in the field, nymphs and adults we observed throughout the year. This graph presents the number of adults which we recorded on sticky card traps. And there are 3 peaks in the year. The one is in late summer, in February, then in winter, in June. and this is the austral summer and obviously the austral winter, and then in spring in September. So the three peaks suggest that we have 3 generations per year. Then obviously the abundance of insects is dependent on temperature and rainfall, and the Western Cape, the Vredendal region, falls into the winter rainfall area. So most of the rainfall is received during winter from April through August, and we can see also that the highest peak we observed from Megenia occurs in June. Then we have got a peak again in September, and then here in January and February. And if we look at temperatures, the temperatures are usually very high. So abundance in the November and December, the summer months, the austral summer months, is the highest temperature, and we've got a very low abundance of Megenia fuscovaria. However, with the grapevine phenology, with the grapevines ripening and during the harvest period, we again, even though temperatures are high, experience a high peak of Megenia fuscovaria. So with regard to the alternative host plants, it's just a quick overview. It was in vineyards and in plants surrounding vineyards were sampled, and we sampled about 1,100 individual plants belonging to 14 families and 33 species. And of these, plants from 7 families and 11 species tested positive for Aster yellows phytoplasma. And these are just some of the examples. So we found positive plants within the Asteraceae. This is the blackjack, Bidens bipinata, a very common weed in South Africa, but also on urtica, on nettle, and also, as I mentioned before, on grasses. And here you can see maize, which also tested positive for Aster yellows, interplanted in young grapevine blocks with grapevine. So you see a small grapevine plant here. So then we also sampled plants in the natural vegetation, and here in the areas where Aster yellows occurs, we have got the fynbos in South Africa, which is famous for its high plant species richness and also high plant endemicity in that region. And then we also sampled in the succulent karoo, which is unique because of its large number of succulent plant species, or the largest number of succulent plant species in the world for an arid area of this size. So there, with the vacuum sampling, we sampled over 900 plant samples from 19 families and 42 species, but only 1 plant species tested positive for Aster yellows phytoplasma. So amongst all these 900 plant samples, we found 2 samples, both belonging to the same species, which were positive, and the species is Mesembryanthum crystallinum, which is occurs in South Africa and the African region, Afrotropical region, but also naturalized in many other parts of the world, in Europe, in Asia, in Australasia, and also the Americas. So considering that only 2 samples out of the natural vegetation tested positive in comparison to the several plant species which tested positive from within vineyards and surrounding vineyards, it is very unlikely that the natural vegetation is the source of Aster yellow phytoplasma, but rather the plants within vineyards may serve as alternative host plants for the vector and also a source of Aster yellows. So based on the results which we have from the surveys in vineyards, and with regard to the seasonal abundance of Megenia fuscovaria and grapevine growth status, we developed a new seasonal management plan which is environmentally friendly and sustainable, and is based on different control measures. It's based on alternative plant host control, weed management, sanitation, and also vector control through insecticide treatments. So weed management is very important because we have shown that several weed species within vineyards are host to Aster yellows phytoplasma and Migenia fuscovaria, which occurs on grapevines, moves on to the alternative to wheat plants in vineyards during the time when grapevine is dormant, and we have observed them feeding on these plants on various wheat species which may host Aster yellows phytoplasma. So then sanitation measures to prevent disease spread include planting of clean Aster-free certified plant material, and also marking and removal of infected plant material. And here the tests which are developed for use in the field come in very handy for the growers to determine which plants should be removed, or sometimes also for the removal of shoots from grapevines. Then monitoring, we recommend that monitoring of Migenia fuscovaria continues throughout the year with yellow sticky traps to base management decision on the timing of insecticide treatments on the population size of Migenia fuscovaria, vine phenology, and the climate. So insecticides for foliar applications have been registered and also for soil benches, and we recommend that these are used based on Migenia population levels in low-risk areas or on the presence of Migenia fuscovaria in high-risk areas. And the management plan is available on the Tropicsafe website under reports and can be downloaded from there. And with that, I would like to acknowledge my co-authors and the following persons and organizations for their support of this project. And with this, I would like to conclude, and thank you very much for your attention.